So here we go. We're talking about double replacement reactions right now. In double replacement reactions, you have two compounds with positive and negative ions. Here is our general equation. We have AB, which would be a metal and a non-metal, reacting with, meaning that it's been mixed in a beaker or a test tube or something like that, with another compound that's got a metal and a non-metal. And when they react, you need to try the other options. You need to put them together in a different combination. So what I'm going to do is I'm going to take this metal, A, and put it with the non-metal from the other compound, which would be D. So that's your first product over here. And then in the other product would be from the metal and the other non-metal combining together to make the second product. So here's our sample equation, our example. We have barium sulfate, which is aqueous, so it's dissolved in some water. Lead nitrate, that's also aqueous. And then they're mixed together. Maybe they're put in the same beaker or the same test tube. And as they are mixed together, these dissolved aqueous ions are going to start colliding together, and maybe they'll make some new products. Well, the barium and the lead cannot come together because they're both a positive charge. So you can't get barium and lead together. But barium could combine with the nitrate, which is what we see here. Barium combining with the nitrate. And then we could also have lead combining with the sulfate. And that's our other product here. Now the next thing we need to do, though, is we need to check the solubility rules. Let's do that. All right. So on the back of our periodic table, we have a whole list. On the back of our periodic table, we have a list of solubility rules. We are dealing with sulfates right now. Let's kind of zoom in on that. Sulfates. It says all sulfates are soluble except for strontium, barium, mercury, and lead. So what this means is that the lead sulfate that we're producing is insoluble. And insoluble means that the state of matter would be a solid. So right here as a product, the lead sulfate is a solid. The barium nitrate is aqueous. Again, we go to our solubility rules, and it says right here, nitrates are always soluble. Always is a pretty strong word there. So you don't ever have to worry about it not being soluble. So there's basically three steps to any one of these reactions. First, you're going to use the charges. You're going to use the charges of the compounds to put together the new pair. So I took the bariums +2, put it together the nitrates -1. Since nitrate's a -1 and barium's a +2, I'm going to have two nitrates in that compound. Lead's a +2, sulfate's a -2, so they balance each other out. I only need one of each. After I do the charges, then I worry about actually balancing the reaction. That's the next piece. Balancing this reaction wasn't very difficult. I have one barium, one sulfate, one lead, nitrate ×2, nitrate's already ×2, so those are balanced. And then the states of matter, again with the states of matter, we're going to go back to our solubility rules. You'll list the solubility rules on the back of your periodic table. Feel free to look them up. The other reaction down here is an acid-base reaction. This is our acid with the hydrogen. That's our base with the hydroxide. Acid-base reactions are really easy to put together. Take the hydrogen and the hydroxide together and you make water. I usually write the water as HOH because it's a little bit easier to balance afterwards. We have two hydrogens here, so I put a 2 in front. Two hydroxides, so I need to put a 2 right here. It gives me two sodiums. I already have two sodiums, a sulfate and a sulfate. So we have charges, balance, and SOM is states of matter. Water is a liquid, sodium acetate. Well, let's see, sodium acetate, sodium sulfate, sulfates are soluble, and sodium's not listed there as an exception. Additionally, sodium is an alkali metal, and they are always soluble. So we have two good reasons to write this down as aqueous. So all of these reactions occur in water. We have an aqueous solution. That means this is dissolved in water, mixed with an aqueous solution that's also dissolved in water. And the sodium and the acetate and the sulfate, the sodium and the sulfate that are mixed in the water could combine together. But when we check the solubility rules, we find out that this compound would be aqueous and therefore just dissolve right back into the water. Whereas up here in this other reaction, when the sulfate and the lead come together, our solubility rules tell us that if lead and sulfate come together in the water, in this mixture of two solutions, they're going to form a solid. And we call that solid a precipitate, and that solid's going to fall to the bottom of the beaker, assuming it's more dense than water.